Thank you for putting this together. I really appreciate it.
Oh yeah, of course. I'm glad you brought it up. Okay, so the whole point of this meeting is just to go over some information about joint sealants and their uses, some ASTM stuff, proper joint designs, chemistries, things of that nature, to try and give everybody a good understanding of joint sealants and so that you can effectively talk to people, things like that. And I know some of you have probably have a fairly deep background in this, and some of you uh, maybe not as deep. And so anyway, we'll just go through it, and if at any point you've got any questions, concerns, anything, of course, just bark out at me. It's fine. So we can kind of go over things. So, okay. So, some objectives are to understand what joint sealants are, to learn about the ASTM standards. The ASTM standards are what are going to drive specifications, whether it's commercial or residential. And then identify the proper applications and joint designs, and then obviously improve your ability to be able to talk with architects, contractors, stuff like that when you're talking about joint sealants, so that they have the confidence that you know what you're talking about. Okay, so a joint sealant, it's basically a product that you're going to use between gaps in building components. It's going to prevent air infiltration and water infiltration, and then it'll expand and contract with that, with those substrates. So they're going to expand and contract thermally. So we need a joint sealant that's going to be in there that will be able to handle that expansion and contraction without failing adhesively or cohesively, so we prevent the air and water filtration. And of course, it's going to be critical to your building envelope performance. Keeping, obviously, water always wins, so if you get enough, you get water infiltration long enough, you're going to have damage problems. So they matter because, they're a leading cause of water infiltration. Obviously, we're sealing to keep water and air out. They also protect structural components from degradation. And any upfront costs in your joint sealant is going to easily outweigh the cost of repairing a structure from water damage. So, and then your obviously inspectors inspect it, and specifiers are going to scrutinize any joint sealant that you're proposing to use. So we need to be able to talk intelligently about these things. So common locations, wall-to-wall applications, wall-to-window and door, so window-door perimeters. When you're talking wall to wall, you may be talking like, say, masonry control joints. If you're not familiar with masonry walls, if you have a masonry wall, every 20 foot on center, you need to put a half-inch vertical control joint in the wall to control movement within that wall. If you don't, you'll get cracking. And so the whole point of the control joint is to control that movement, and then we want to seal those joints to prevent the water and moisture or moisture and air intrusion. Expansion and control joints in concrete, floor to wall perimeters will sometimes be done, roof and wall penetrations as well. Sealant chemistry overview. So polyurethanes are going to be, they can get good movement capability. They can be pretty durable, but they have low UV resistance. So when you have high UV exposure, which, for instance, a lot of concrete will typically have high UV exposure, whether they're tilt-up panels or slab-on-grade expansion joints. The UV will do a number on them, and it won't last very long. They also contain solvents, anywhere from 15 to 20%. So anytime something contains a
So you're
solvent,
basing
you know
everything
that
off with what you have there.
it's going to
You
shrink as
don't
well.
have a header, so
Hey, can you guys everybody mute themselves so any background noise doesn't come through? Appreciate it. So anytime you have solvent in your material, that's going to evaporate off, and when it evaporates off, the material is going to shrink. And so ideally, we don't want shrinkage, right? We'd like it to be a non-shrink product, which of course is what our product is. And then silicones are UV stable. They can handle a lot of movement. You can use them in a lot of applications. They'll use them for a lot of glazing. You can use them in masonry systems, concrete systems, etc. They tend to be a little more expensive than some other products. The other thing is they're not paintable. So if you're going to use it on a surface that needs to be painted, or they think they may want to paint it, say 10 years down the road, then you probably want to avoid a silicone. And then the hybrid products like ours, they can handle high movement. You can use them on damp surfaces. They have excellent UV resistance, paintable, low VOC. All this information that you pull off of our data sheets as far as this is all like, if you're talking about a polyether product, then any polyether is going to have these types of characteristics with the VO or the low VOC, they're non-toxic, non-shrink, those types of things. And then you have acrylic latexes, which are for interior applications and low movements. A lot of them will be acrylic latex plus silicone, so they can handle like maybe 12.5% plus or minus for movement. And then you have butyls, which are for flashing and roofing details. So sealant comparisons, again. And some of this stuff I'm going to go over a few times, so we try to hammer some of it home. So sealant comparisons, your polyurethanes, like I said, contain solvents, so they shrink. They have the low UV resistance. So I did a little homework on the low UV resistance. So says they contain aromatic structures that absorb UV light, and so that's what causes degradation within the polymers. These, if you've ever seen somebody use a polyurethane in an exposed application, especially lighter colors, they yellow really easily from UV light. So, and that can be a problem. You come in one day, you caulk a bunch of vertical control joints in, and you come back 2 days later and they're yellowish orange, and so that's a problem, of course. They can outlet gas on damp surfaces. They have a long skin over time. Can be a plus, can be a minus. If you're doing slab on grade concrete joints, it's a minus because people can step in it and pull it off on their shoe and track it around. But, we used to do window perimeters, and I could spend half a day running window perimeters and then go back and finish the joint off and it'd still be fine. So it can be good and bad. So again, they meet movement requirements, but UV exposure causes yellowing. And so where you have appearance that matters, our products are going to have superior color stability. And then, of course, ours, MS Polymer, has excellent UV resistance, doesn't outgas on damp surfaces, non-toxic, non-shrink. It's 100% solids. So, 100% solids just means the solids are just the part of the sealant that's left over after anything has evaporated off of it. And they have excellent adhesion to a variety of substrates. As we know with our products, the climate products, we're concrete, masonry, glass, asphalt, a number of different applications apply, and they're low VOC. And then we have silicones. Silicones have excellent UV resistance. Certain silicones have damp surface compatibility as well. They tend to be more expensive than other formulations, especially depending on the products you get into. They're not paintable, and non-silicone products will not bond to silicone. Basically, the rule of thumb is that the only thing that bonds to silicone is silicone. So if you have somebody putting a wall coating on, for instance, that's a silicone-based wall coating, you want to use silicone in those joints. You wouldn't want to be using our product. And then ASTM standards and why they matter. So ASTM defines the performance, not the brand. And we'll go over the main ASTM standard that will give all that information. But most architects are going to reference ASTM standards in their specs. If you've ever been through a joint sealant specification for commercial work, that's how they specify the product based on ASTM C920. And then that ASTM compliance reduces liability and risk. So, you're using the right product for the right application. And so we have to be able to speak fluently about these ASTM standards. Again, the main one is ASTM C920, which is mostly what you would probably talk about. So, like I said, here's the ASTM C920. It governs the performance of most construction sealants. It's used by architects, engineers, and inspectors, and it's required for most commercial and residential specifications. So getting into C920 classifications, when you read it'll say ASTM C920, then it'll go type, then grade, then class, and then use. And so your types, S is single component, M is multi-component. Grade, you have non-sag and pourable, so obviously pourable is your self-leveling type products. And then class describes movement capability. So it'll be anywhere from 12.5% plus or minus to plus or minus 100 or plus 100 minus 50. And then uses, T is traffic, NT is non-traffic, M is metals, G glass, A aluminum, O is other. So this is going to describe some of the substrates and whether or not it can be used for traffic-bearing applications. You determine whether or not it can be used in traffic applications based on what's called Shore A hardness, which I don't have on here, but the Shore A hardness. If it's above, I believe it's 25 Shore A hardness, then it can be used for traffic applications. ASTM C719 movement testing. So cyclic expansion and contraction testing. So when you talk about expansion and contraction with joint sealants, you're talking about it throughout the width of the joint. So your elongation is obviously when you try stretching like so, and then your expansion and contraction is through the width of the joint like this way. So, and then it confirms adhesion and cohesion during movement, predicts real-world performance, and prevents cracking and joint failure. Or I don't know if it prevents it, but maybe it predicts it. Anyway, ASTM C794, adhesion and peel testing. So it's going to give you a pound per linear inch given from a certain substrate. It evaluates the bond to those substrates, obviously determines primer requirements. So if you have poor adhesion and peel, say to concrete, then it may be that you need a primer. And it's critical for warranty protection. Okay, proper joint design and installation practices. And this is probably where I start repeating myself a lot so that we kind of get this stuff in our heads. So the vast majority of sealant failures are going to be due to applicator error. You know, it's not that often that you have a product showing up from the manufacturer that's defective. You know, when we send our stuff out, if you apply it properly, it's going to work the way it's supposed to. Obviously, there's exceptions, but for the most part, if you have applicator error, that's where the majority of your failures are going to come from. So examples are like contaminated surfaces. You know, we want a clean surface to seal from. So dust is your enemy, dirt, oils. We don't want standing water, things like that. You know, the ideal is a clean, fairly dry surface. Obviously, for us, we're compatible with damp surfaces, and so that's not as big a deal, but we don't want standing water on them. We don't want frost on them, things of that nature. Another thing is poor width to depth ratio. So you want a width to depth ratio of 2:1. So if you have a 1-inch wide joint, then you want in the center of your joint, you want that sealant to be no deeper than a 1/2 inch. Or if it's a 1/2 inch joint, you want a 1/4 inch joint in the middle, 1/4 inch depth in the middle. And then typically it's recommended that your max depth is going to be 1/2 inch. So even if you go up to a 2-inch wide joint, you're only going to want a 1/2 inch of depth. And you know, your width to depth ratio is what is going to control the movement of that joint, or the ability for that sealant to be able to move in that joint. And well, I've got another slide that is a visual of it that tells you the different stresses that are on the joint based on different depths, or width to depth ratios. So we'll look at that in a minute. And then improper backer rod installation. So our backer rod is, depending on the joint design, is going to give us our 2:1 ratio width to depth. But what we also want in that joint is consistency of the depth. So you don't want it a 1/2 inch depth at the bottom of your joint, and then as it creeps up, you're getting up to a 1/4 inch or something to that effect. You want it consistent throughout that joint. That way the joint moves consistently as well. And then use of solvents and soaps for tooling. Obviously, solvents and soaps can taint your bond. So when we run out a joint, we recommend dry tooling those joints. And what we do for dry tooling, they make these steel slicks for tooling off your product. And basically, what these slicks look like are pastry knives that you might use for pastry on a cake or doing frosting on a cake, something like that. And they'll come in different widths. They'll be up to, say, 2 inches wide down to a 1/4 inch wide. And what we would do is we would custom grind all of these slicks to whatever sizes we needed for depending on the joints we were working on. But this way you don't have anything brought into the equation that's going to taint your bond, so that we can achieve maximum adhesion. And then if you're a lack of a primer, if it's needed, obviously is going to be a problem for joint failures and improper selection of joint sealants. So, if you have a dynamic joint and you're using a class 25 sealant, you're probably setting yourself up for failure. You're going to want to use the class 50s or better.
Rod, I've got a
Yeah.
question about the wet application. When we were promoting ChemLink M1, one of the great things about that product was that it could be used for emergency roof repairs, and they actually used to do demonstrations where they'd take a leaking fish tank and would apply M1 underwater, and within 20 minutes it was going to skin over. And so we used to promote that quite heavily as an emergency roof repair system. Can we continue to do that with Climate NS, or are you suggesting that we?
Yeah, I mean, we can do that. I've done the exact same test, and it works fine, but it's not a long-term fix, right?
Absolutely.
You want to do that for, you do it to fix it temporarily until the roofers can get there and do a permanent fix.
Right.
So yes, it will. I can shoot it underwater. I can tool it off underwater, and it'll cure and it'll seal. But I wouldn't count on it for the long term.
Absolutely.
So,
okay. Thank you.
Yep. And then again, proper joint design has a ratio of 2 to 1. It's not going to expand and contract with the substrate if the material's too thick. So if you think about that, it'd be like if you had a piece of rubber that's a 1/4 inch thick, you can grab it and you can pull it from side to side pretty easily. But if it's a 1/2 inch thick, you can't hardly move that thing. And so it's the same kind of thing. Not only does it not move very well, but it creates a lot more stress on the bond lines as well. And so you want to use your backer rod to create consistent depth throughout that joint and give it that 2 to 1 ratio that you want. Sometimes you can't, there's not enough room to get a backer rod in there. And so you're going to use something else to, and we'll talk about that in a little bit, to prevent what's called 3-sided adhesion. But we'll talk about that in a minute. So the ideal joint design for a receiving backer rod has an hourglass shape. So let me see if I can find that. Okay. So if you look at this one in the front here, number 1, you can see that it's rounded on the bottom where it meets the backer rod, and it's concave on the top. So what you get in the middle is an hourglass shape. That's your ideal shape. So the middle of this joint is going to be 1/2 the width. On the edges here, you can see you've got more depth. So you've got a larger bond line there. And in the middle, you reduce that depth so that you get the movement. In the second one here, you can see how this dotted line shows the backer rod is uneven in the joint. So in the front part of the joint, you have proper depth to width ratio, but then as you go back, it gets thinner and thinner. And so you're not gonna, that sealant's not gonna work the way it's designed to work there. And then this last one, you don't have enough depth, so then you end up with a cohesive failure. The material splits right down the middle. So obviously, installing Baccarat is a big deal as far as doing it properly to get your sealant to work the way it's designed to. Okay, and then joint width must allow for movement. So like if you look at, you see people that they'll have cracks in their driveway or something like that, and they'll go grab a self-leveling and just drop it in, right? And maybe it's an 1/8-inch joint. Well, an 1/8-inch joint doesn't have enough area for the sealant to be able to work properly. Typically what we would do is open those joints up with a grinder so we have at least a 1/4 inch. So you have to have a minimum width, and most manufacturers are going to recommend at least a 1/4 inch in order to be able to have enough material with the cross section needed to be able to handle those stresses that come along that are on that bond line. Let's see, I just talked about the joint width to allow movement. Proper depth, again, controls performance. Typical width to depth ratio, again, 2:1. Poor joint design is going to equal sealant failure. Here's your Baccarat again. Okay, here's the slide that shows the joint to, or the width to depth ratio. So this first one, you have proper width to depth. This first image, you have no strain on it. When the joint opens up due to thermal expansion contraction, you got 32% strain. And then on the far right, you see when the joint closes, you get 20%. The next one down, where your depth equals width, you get where it opens up. Now the strain is 62%, and when it closes, you're at 60%. Trying to move this thing around so I can see. And then on the third one down, your width is 2 times your depth, and so, or your depth is 2 times your width. Sorry, and so your strain in expansion becomes 94%, and your strain in contraction becomes 250%. So if you're going out and just filling joints, to full depth, because you don't want to install Baccarat, or maybe somebody doesn't know whether you should or not, the benefits of it, this is what you're looking at. You're pretty much guaranteeing failure. So let me see here. Okay, importance of Baccarat, again, we'll go over. Controls sealant depth, prevents 3-sided adhesion. So 3-sided adhesion is basically just like it sounds, where the sealant adheres on 3 sides. And when you have that, you put a lot of strain on your, not only on your bond lines, but cohesively. It was explained to me before, like if you have a 50% joint movement, you get to a point in that joint where, if it's bonded, say, all the way across the bottom, at the middle of that joint, basically, it's, going to be 50% of 0, and 50% of 0 is 0. So you don't get that movement. And so then you start getting into cohesive failures and adhesive failures. So if you don't have enough depth in the joint, one thing you can use is a bond breaker tape. So they make a polyethylene tape that's designed for these applications. It's always recommended not to have three-sided adhesion. It happens extensively, Basically, almost nobody uses a bond breaker tape. Not that I've seen anyway. Probably should, but I bought I think 5 rolls of it once, and when I sold my business, probably 5 years later, I think I had 4 3/4 rolls left. So that's how much it
What is bond breaker tape all about? I've never seen it.
Yeah, it's just a black thin tape. Probably you get it in different widths, and so you can lay it down in the bottom of your joint, and that'll prevent that three-sided adhesion.
Got it. Okay.
So, and your back rod is going to improve your movement capability because again, you're controlling the depth of the joint, which is the key here. And then obviously you're reducing material usage and waste, right? So if you're filling that joint full depth, say it's 3/4 of an inch deep, well, you're going to use a lot more material than if it's a half or a 1/4 inch deep. So, and then importance of back rod, choosing the correct back rod, and I think that's the next slide here. So, back rod types, you have a closed cell back rod. So closed cells, they won't absorb moisture. If you puncture them, though, they can cause your sealant to bubble. And, they don't compress very easily. I always found them a hassle to use, so we didn't use them that much. Open cells are basically used for interior use because they will absorb and hold moisture. And if your back rod is absorbing and holding moisture, then it's going to lead to a sealant failure eventually. Like I said, water always wins. We didn't use a lot of open cell either. We would use the bicellular because it basically has the properties of both. It compresses easily, doesn't absorb moisture. It's the most common product out there that people use. Basically, we refer to it as soft rod. I think it's even marketed as soft rod as well. At least some people do. Common causes of sealant failure. Again, contaminated substrates. We want clean substrates. Incorrect joint dimensions. We want to get the joint depth to width ratio correct. No back rod. If you end up with three-sided adhesion, stuff like that, or inconsistent depths in your joint, you're going to get failures. Wrong sealant chemistry. So maybe you're doing precast concrete panel joints, tilt-ups, and it's high UV exposure. If you're using a polyurethane, they're not going to last. We did Stryker Medical is right down the road from here, and probably 5 or 6 years after they built it, they called me and had me come out and look at it. And all of the exterior precast concrete panel joints were failed on the east, south, and west elevations because of their exposure to UV, because they had spec'd the polyurethane for the project. So we went in and removed all of the sealants, prepped all the joints, and then resealed them at that time with a silicone. And so, 5, 6 years after you build the thing, now you have to spend about 3 or 4 times what you did to do it the first time. So it's a big deal, And then obviously poor installation practices will cause sealant failures. You're not back rotting right. You're not maybe you're not priming joints the way you should, you're not dry tooling. All of those things are going to lead to failures. Oops. Okay, and then how we want to be able to sell is, we want to sell performance. So our performance, if you have questions about performance, we want to, the first place to look is at the data sheet. We want to know the data sheets really well, and the ASTM C920 is going to tell us a lot of what we want to know as far as, single component, what type of materials it's good for, classifications for expansion and contraction. And then some of the other stuff too, of course, your shear strength, the elongation we're always promoting because we have such good elongation with NS and SL. And then position our sealants as engineered solutions, so that, we design these sealants for these applications that we're selling them for. And then we emphasize risk reduction. So if you're using the right product for the right application, then you're reducing the risk of callbacks. And, those callbacks, you can use a cheaper product, but if you get one callback, you're probably going to wish you had spent a little bit more, because then you're probably going to be spending more just from one callback. And then support spec-driven conversation. So we want to be able to talk about these ASTM standards and the information on our data sheets with specifiers, builders, subcontractors, all of these people we need to be able to have intelligent conversations with so that they understand that we know what we're talking about and we're people they can turn to, especially, for questions and stuff. I used to do work for one of the biggest masonry contractors in the state, and I had a good relationship with them, and they would call me up and ask me questions about projects that they were using somebody else on. So we want to be, that's the kind of people we want to be, is, somebody that our customers have confidence that, we're the professionals, we know what we're talking about, and they can turn to us. Questions we should be asking, what are your applications, interior or exterior? Obviously, climate products can be used for either application, but maybe they're looking at a project and they're considering using a project that's not designed for an interior application or an exterior application. And so we can call that out for them and let them know that they're about to use the wrong product. Expected joint movement. So again, which product to use, substrate types, UV exposure, things like that, water, whether they're continuously submerged, are you having traffic exposure, is the project spec driven or is it contractor driven? You're probably going to have a different conversation with a contractor than you may with, say, an architect. So we want to be able to talk to either one of them. Objection handling, just a couple of simple things. People think all sealants are just caulk. They're all the same. And so this is where the ASTM C920 and the classifications can help us. Again, that's going to describe different expansion contraction ratios. And then we can have a discussion about the work that they're doing and which product would be best for them. Cheaper works fine. Again, this is about callbacks. I went to a conference up in northern Michigan for hardscape guys, and one of the guys up there who's now buying stuff from us was like, he knew that our product cost a little bit more than what he was currently buying. He's like, but once I get one call back on it, I'll wish I would have spent a little bit more, because then all of a sudden ours is cheaper, or less expensive, I should say. And, people who don't want to use primer in certain applications, obviously we don't need a primer for everything we do. We need to be able to compete with those companies that basically say you don't have to prime just about anything. But we just went over this with this parking ramp they're building here in Kalamazoo. We're trying to get inclusion into the specification, and we did a presentation with the construction manager and stuff like that. And I had a lot of pictures from parking ramps of failed joint sealants, and then all the spalling that ends up coming as a result of some of that. And you can save yourself a little money by not priming on the front end, but in the long run, if you're looking for maximum adhesion, especially in a critical project, you should probably be priming it. Otherwise, they're setting themselves up. So some key takeaways: ASTM C920 is the baseline standard. This tells us a lot of what we need to know about any given joint sealant. So if you're looking at another product, say a Sika product or something like that, this is probably the first thing you want to look at on their data sheet is ASTM C920. It's going to tell you a lot of what you want to know. Movement capability is going to will be one of the things that drives product selection. So if you have a dynamic joint, then you're going to want to use a more dynamic sealant, obviously. Less dynamic, then you can go to the lower class joints where you're probably not going to spend as much money. And then installation quality matters as much as choosing the right product. If your contractors aren't well versed in proper application standards, or if they really don't care about them, then that's going to be a problem. You're going to have joint failures. And then, when we're out there, we want to be selling confidence and compliance. If we're selling a high quality product that's going to do what they need it to do, and that it's going to comply with any specification. And that's about it. This would be the question and answer period, if anybody has any.
Are you going to share these slides with us?
Yeah, I was thinking I may put them on the website so everybody can access them.
Okay, great.
Quick question. The SL and the NS, as far as expansion joints, if you use the NS on a horizontal expansion joint, will we still have the ASTM compliance?
Yes. Yeah, I mean, basically they're pretty similar chemistries. When you look at the data sheet, about the only difference you're going to see is in the viscosity. So they're both class 50s. They both get, up to 1,000% elongation, all of that stuff. So the main difference is one's a self-leveling and one's a non-sag. So, you have, there's a lot of contractors don't like self-leveling, because if that joint isn't prepped properly and then you fill it with a self-leveling, that stuff's going to sink to China. So then you got to go back through and figure out where your sinkers are and plug them and shoot it again. And then inevitably you missed one. So you got to go back through and plug those and shoot it again. And so, I look at I know guys that use SL. It's not that people don't use it, and then you have a lot of guys who will use it simply because they don't know how to finish off a non-slump product and make it look nice, and make sure it's sealed. So there's different reasons out there that people will use it. Now, if you can stuff a joint yourself with a back rod and do a nice job with it, then it's great. Then you don't have to tool it. You just shoot it and walk away. But so yeah, but it's NS is fine for horizontal slab on grade work.
As far as the NS goes, if you have a, like a relatively wide joint and you put the backer rod in, is it a bad idea if you don't want to do the tooling? Is it a bad idea to go in there and put some NS and, hit it down with the tool so it locks everything up and then come back and do the self-leveling on top? As long as we stay with the proper ratio.
Yeah, making sure you don't get sinkers and stuff like that. Yeah, we've done that before. I've gone through with like expansion joints and sealed the edges with just a little latex, just to fill holes and stuff, and then come back with the SL and finish it off.
Yeah, because that could save a lot of time on tooling.
Yeah, especially if you don't know how to tool.
Who wants to be on their knees for that long?
Yeah, right.
The young kids, and the young kids aren't interested. And what about because I missed a little bit of the thing, I had a problem with Zoom. What about the usage in wood construction for air sealing, using it for application of your subfloor, things of that nature? Did we touch on that, or that's not part of this educational module?
No, we didn't get into that. This is purely a joint sealant session. Obviously we can do that with NS being used as an adhesive application within framing systems. We've all talked about that stuff extensively, but for this session right here, it's all about building up some knowledge base on joint sealants, and like I said at the beginning, is like, some people here have extensive knowledge in joint sealants, and other people need more of a background on it. And so for some people, it's just this is a bit of a refresher, and for others of us, it's a little more than that. So.
The Rob, the GP, certain joints you may need to get apart later, and the NS is you got to wreck it to get it apart. How do you advise people whether they should use the GP or the NS?
Well, it depends, what you're using it for. I mean, like, if I'm sealing certain joints and I want to get it apart, if I take a nice sharp razor knife to a joint with NS in it, I guarantee I can get it out.
I got you. Yeah.
I mean, if you're using it as an adhesive, like to set a window in, that's a different situation than running a perimeter bead around a window frame or something,
Right.
So, but it'll come out with a nice sharp blade if you have that application, So what you got to determine mostly is what kind of movement you think you'll get between the two substrates, So if you've got an aluminum window frame, well, that thing's going to move a lot thermally, so you should probably use a material that moves more. But if you're talking like, a vinyl window or something, well, that's not going to move near as much. So that's the deal. You got to figure out, whether you have dynamic movement or not. And if you do, then, you got to choose accordingly.
A question regarding marketing, now that things are starting to happen and you're doing some various jobs around the country, is there the possibility of doing project profiles on your website? Because a lot of times we get questions like, where is it being used? How is it being used? and people love to see proof of concept with these kind of project profile presentations or features.
Yeah, I mean, I think we have the one up there from the passive house we did up in just north of here, and then we've got another one we're working on right now from a different passive house as far as using NS with it. We don't really have stuff on there for joint sealant stuff. I mean, we've moved a little bit of product out in Iowa with a concrete distributor. We have Benson Wood Homes over in New Hampshire is starting to use NS as an adhesive, so maybe at some point we could work something out with them. I'm not sure yet, but certainly as those things come in, we will be we're highlighting them. It's just that you guys know they've been far and few so far. So,
yeah. Has anyone had any success in approaching the solar companies and having them replace M1 and one part with NS and SL? With E-curbs and chem-curbs and things like that?
No,
to my knowledge, I don't know if that's been pursued really.
Yeah.
Anybody?
Yeah, we've spoken to a couple of distributors out here, and the biggest obstacle that we've faced so far is because these people still need to go back to ChemLink to get their E-curbs
and there's silicone.
Right.
and silicone in applications where that's necessary. Is that they are having trouble meeting their $5,000 minimum order to get the free freight from the factory. And so the temptation is to pad the order with M1 and one part. So that's been our problem, but it's a very small market out here.
So have you guys had any luck with finding other people that make curbs that are, that
Really?
work?
Nothing like an E-curb. Yeah. No, we've done a lot of searching online, and no, really haven't. How about you?
Not really. I mean, I know one company that last I knew they're planning on doing something with them, but there's a lot of legal stuff that they're going through before they can roll anything out and stuff like that. And so, and that's been in the works for quite a while now. So,
we ran across one company, and I'm forgetting if it was GAF or who it was, but they had E-curb copycat, but they were only making them available in rounds and in a very limited range of sizes. Right. And the thing that we found is that these solar distributors like to have everything from 3-inch up to 8-inch on the rounds, but they do a fair amount of business with straights and 90-degree corners to tackle multiple penetrations. A single circular product is not going to cut it.
Yeah, I think I may have seen those as well, but they were kind of they didn't have the a wide range of functionality to them,
Yeah,
would do
exactly.
certain things, but that was about it, so I think
because if we could find a way to get curbs, that curb aspect addressed through a different company, so that these solar guys didn't have to rely on ChemLink for anything, that would be very interesting, because at least over here in this market, that was one of the strongest parts of the ChemLink offer, and they probably sold more to solar than anyone else.
Personally, I'd like to see us making them, but Phil doesn't want to whack a hornet's nest.
What about silicone? Is there any chance that we would have a silicone line coming on board?
Well, there's been zero discussion about that. So
Okay.
I don't know. Maybe that's an option for down the road, but right now there hasn't been any discussion about it. No.
Okay.
On the uses for the SL and the N1, we have T on there for traffic. What's T1 referring to, or is it just traffic?
That's a good question. I'm not positive on that. I have to
But
look at it.
both products are good for parking lots and
Oh yeah,
things like that.
yeah.
Okay.
Is silica sand recommended or to be avoided?
I don't see any reason why we couldn't use silica sand on it. You're talking to on the surface, keep
Mhm.
it from sticking.
Sometimes
blending,
color, sometimes aesthetics, sometimes just overall, wear and tear.
Yeah. Looking up what T1 is. See if I could find it.
No, this was a really good overview. It'd be cool to get this in like a PDF or something, just to, kind of get this in front of people we've done trainings for.
Okay. Yeah, I can do that.
It's a nice refresher.
Mm-hmm. Yeah, and I'll also put it on. I'll get Nate to put it up on the website. So if anybody wants to go back over it.
I bet if you put it up on YouTube, you'd get more views than you would imagine, because it's a lot of really, really good information that you
Yeah.
might not be able to find easily elsewhere.
Yeah.
So
And it's
thank you.
Yeah, and
Okay.
it's easy to
Yeah.
share that link.
Yeah.
Yeah.
It looks like
Creating-
T1 has to do with temperature. So it says T1 is sealants that are installed above 40 degrees, and T2 is less than 40.
Okay.
Guess I didn't know that one.
We're T1.
T1 for NS and SL, yes.
Yeah.
That's probably just relative to the curing, right? If we get too cool, it's going to take us a little bit longer to cure.
Yeah, exactly.
Interesting.
The creating context with PDFs is not always the easiest thing, and videos and discussions really, really help get people's attention and create context for them. And they don't even have to watch the whole thing necessarily. They hear that one thing and they start imagining and they start asking questions.
Hmm.
So I agree with Lady Mary